Welcome to Camp Turing. Pointers are one of the most important and most often misunderstood features of C and C++. The first step in understanding pointers is visualizing how the main memory, also referred to as RAM, is organized in a computer. Suppose we have a RAM of 10 bytes and this RAM is byte addressable. What I mean by byte addressable is that our RAM is logically divided into these cells, such that each cell is of 1 byte capacity, and each of these cells is allotted a unique address. As you can see, we have 10 cells in this RAM. The first cell has been allotted the address of 1001, and the last cell has an address of 1010. An executable program consists of data like an int variable. Depending upon its size, a variable occupies 1 or more bytes in the memory. An int variable generally occupies 4 bytes. That is, it needs 4 cells in our memory. Let's say the compiler allots these 4 cells to the variable a and then stores the value 7. The address of the first byte is said to be the base address or simply the address of the variable. So, the base address of A here is 1001. Now, here is where the pointers come into the picture. A pointer is nothing but a special variable that points to some entity in the main memory by storing the base address of that entity. By entity, I mean any instance currently present in the memory. It can be a variable, an array, structure, function, a C++ object, or even a pointer itself. Suppose we have a pointer and variable named var in the memory. The pointer will not point to var until and unless base address of var is not stored in the pointer. Now let's see how the pointers are declared, assigned, and used. Here is the declaration and assignment of variable a. It is necessary to declare a variable with its data type before using it so that the compiler gets to know how much space needs to be reserved for it. A pointer is declared in much the same way as an ordinary variable. The data type is followed by the name of the pointer. The only difference is we have to either succeed the data type with a star or precede the name of the pointer with 1. Both the syntax will work, however I prefer the first one as it is quite simple to understand. Here you can see that int is the data type and a is the variable's name. A is a variable of type integer. Similarly, you can see that ptr is the pointer variable's name, while int star is the data type. So ptr is a variable of type pointer to int. That is, p is a variable that is capable of pointing to variables of type int. Remember that a pointer's data type should match with the data type of that variable which should be pointed by it. If you want a pointer to a float variable, write float star or cat star in the case of a char variable, and so on. Any pointer can be either of the size 4 bytes or 8 bytes depending upon your system. So let's suppose ptr is of 4 bytes. As soon as compiler encounters this declaration, it comprehends that the variable is a pointer and reserves these 4 bytes. Notice that there is nothing stored in the pointer yet because we have not stored anything to it. So let's do it. For assigning the variable to a pointer or any other entity, precede it with an ampersand symbol. Thus now the address of a, that is 1001, is stored in ptr. And as we say, now our pointer ptr will start pointing to a. This operator is called the address of operator and is used to access the address of entities in memory. Now let's see what is pointer dereferencing. After the pointer is initialized, preceding its name with a star will give you access to the variable that it points to. Since ptr points to a, star PTR will give us access to A, and thus when we try to print star P, it will print the value of A. This process of accessing or manipulating the data contained in the variable pointed to by a pointer is called dereferencing. This operator is called indirection operator, and keep in mind that this star is different from the star used in the declaration. Here it is used as a syntax rule, whereas this is an operator. To understand the working of indirection operator better, we can think of the indirection and address of operators to be multiplicative inverses of each other. This is only an analogy for better understanding. Now let's see what happens when we precede our pointer PTR with the indirection operator. Plug in the value of PTR and you get this, since PTR has AND A stored in it. Now we know that inverses cancel each other out and we are left with A. So star PTR is same as A. Now let's see some statements and their outputs. Just like other variables, you can declare and initialize a pointer in the same statement. Print A will obviously give you an output of 7, as 7 is the value of A. Printing PTR will result in 1001 since this is what is stored as its value. Address of operator will fetch the address of A and thus it will also print 1001. Printing the address of PTR will result in 1007 as this is the base address of PTR. Dereferencing PTR will give us the value of A, that is 7. In this statement you can cancel out the indirection and the address of operators and you will be left with A, that is 7. Now let's increment A and try to dereference PTR again. It will print 8. Now let's dereference PTR again and this time assign a value of 5 to it. Print A, the output will be 5 now. Here we are incrementing after dereferencing PTR. Let's print A again. Now it's 6. And dereferencing PTR will give us the same result. As an exercise, you can solve this statement and leave your answers in the comments. We will continue pointers in the upcoming videos. Please like and share the video and subscribe to Camp Turing.